Welcome to maths classes. Today we'll learn the progressions from the 10th class maths book. Okay. So for the reference, I will be using Telangana class 10th maths book for explaining the progressions. Okay. The theory will be mostly covered in that book. That's why I'm choosing that. Okay. And all the exercises we will be solving. And parallelly, I will run a thread on questions from IOKM and entrance exams with respect to progressions. Okay, that will go on another videos. Okay, so yeah, here is what we learn in this videos. Okay, in this video we will limit for up to arithmetic progression. Okay, so we will see the chapter 6 in the Telangana maths class, introduction, arithmetic progression, then exercises, how to find the nth term of the arithmetic progression, then more exercise, then sum of n terms in arithmetic progression and more exercise related to that. Okay, in the next video we will learn about the geometric progression. So let's start. Introduction to progressions. Okay, you might have observed several things in the nature. Okay, many things follow certain pattern. Okay, and as a mathematician, it's our interest in finding the patterns and solving the problems, right? So some of the patterns you can find is petals of a sunflower, and then cell of a honeycomb, grains of a maize cob, and spirals on a pineapple or a pine cone. Okay, so each one has some certain patterns to follow. Okay, right? And these are all some of the patterns which we see in the nature. Okay, and we see that natural patterns have a repetition which is not progressive. Okay, the identical petals of a sunflower are equidistantly grown basically, right? And in a honeycomb, identical hexagon shaped cells are arranged symmetrically. Okay, identical hexagon shaped are arranged symmetrically around the each hexagonal cell. Okay, so similarly like this you can find several patterns in the nature. Okay, uh, let's see some examples actually with the numbers. Okay, list of last digits taken from the values of 4, 4 square, 4 cube, 4 power 4, 4 to the power of 5, 4 to the power of 6. Okay, it looks like we might be getting some kind of pattern here. Let's see, 4 we know the last unit digit is 4, 4 square is 16, so 6. Okay, 4 cube is 64, 4. So if you see that they all follow a pattern called 4 6 4 6 4 6 4 6. Okay, so all the powers of 4 actually they follow a pattern 4 6 4 6 4 6 4 6. Okay, so this is the pattern we have to observe actually, right? So these are all very useful things actually if you observe, and you might have seen some of my videos on remainder theorem, how useful knowing this pattern that 4 to the power of n follows a pattern 4 6 4 6. Okay, we solved several problems using this. Okay, another example, Mary is doing problems on patterns as part of preparing for a bank exam. One of them is find the next two terms in the following pattern. Okay, 1 2 4 8 10 20 22, like this. Okay, so do you see any pattern in this? Okay, do you see any pattern in this? 1 2 4 8, everything is like either, I mean, I would say double. Okay, 1 become 2, 2 become 4, 4 times 2 8, but here it is not. Okay, so if you consider these are all even numbers and 6 is missing, okay, then 12 and things. So watch carefully, observe carefully if there is a pattern in this. Okay, then next, another example, Usha applied for a job and got selected. She has been offered a job with starting monthly salary of 8,000. Okay, starting monthly salary of 8,000 with an annual increment of 500. Means after 1 year she will get 500 rupees more. Okay, that means if her initial salary is 8,000, after 1 year she will get, okay, first salary is 8,000, after 1 year she will get 8,500. Next year she will get 9,000 and so on. Okay, so here we can see a pattern, right? Every year she gets 500 rupees more per month, right? Monthly salary. So there is a some pattern here. Next, the length of rungs of a ladder decrease uniformly by 2 centimeters from bottom to top. If the bottom rung is 45 centimeters length, the length of the first, second, third, and so on up to 8 rungs from the bottom are, okay, from 45, and every time it decreases by 2 centimeters. So 43, 41, 39, 37, 35, 33, 31, like this. So this is a pattern here, right? Decreasing by 2, right? So we can see a lot of patterns in the regular, I mean daily problems and problems mentioned here, examples. Okay. In the pattern 1, 4 and 6 are repeating. That's what we discussed, right? Similarly, other things we discussed. Okay. Salary, yeah, there is a 500 increment to the preceding year. Okay. And then there is a 2 less from the preceding number here. Minus 2 is the, if you subtract 2 basically, or add minus 2. Okay. Now, let's see some more examples of progressive patterns. Okay. In a saving scheme, the amount becomes 5 by 4 times of itself after 3 years. Okay, which means if you put 1 rupee, it will become 5 by 4 after 3 years. Okay, example that is. So the maturity amount of investment of 8,000 after 3, 6, 9 and 12 years will be, okay, 10,000. You need to apply the simple interest formula, that is the PNR by 100. Right, that's the interest, and add it to the principal. 10,000, 12,500, 15,625, 19,531.25, like this. Okay, so do you see any pattern in this? Any kind of pattern in this? Okay, now another example. The number of unit squares in a squares with sides 1, 2, 3 units are respectively here. This is 1 square, this is 2 square, this is 3 square, and so on, right? So this is one kind of sequence. Okay, Hema put 1,000 rupees in her daughter's money box when she was 1 year old and increased the amount by 500 every year. This is similar to the salary problem we saw, right? Okay, the amount of money in the box on her first, second, third, fourth and birthday would be 1,000, 1,500, 2,000, 2,500 respectively, right? It will grow like this at this rate. Another example, the fraction of first, second, third shaded regions of the squares in the following figure will be respectively like this. This is 1/4 of the complete square, right? And this is 1/4 of the 1/4, that is 1 by 16. Okay, this is 1 by 64, this is 1 by 256. Okay, 4 to the 1 by 4, 4 square, 4 cube, 4 to the power of 4. So this sequence goes on like this. Okay, so this is another sequence here like this. Okay, now another thing is, a pair of rabbits are too young to produce in their first month. Okay, in the second and every subsequent month they produce a new pair. Okay, each pair of rabbits produce a new pair in the second month and every subsequent month. Okay, assuming no rabbit dies, the number of pairs of rabbits at the start of the first, second, third dash dash respectively 1, 1, 2, 3, 5, 8. Let's see the example here. We have first month, we have one pair of rabbits here. Okay, they can't produce in the first month, but second month they produce. Okay, right, so it's here, and it will continue producing every month after that, like this. Okay, but this rabbit rabbit which was born in the second month, okay, this will start producing from the third month, correct, like this. Okay, and this one it will start producing from the fifth month, fourth month, and like this. Okay, so if you see the total number of rabbits, there is one pair here, one pair here, there are two pairs here. Okay, there are three pairs here, there are five pairs here, there are eight pairs here, right? So it grows like this. Okay, do you see any pattern in this? This is example of a Fibonacci number. Sum of one, each number is sum of the two previous numbers. 2 is 1 plus 1, 3 is 2 plus 1, 5 is 3 plus 2, 8 is 5 plus 3. Okay, it is going on like this. Okay, so in all those examples you see most of the these numbers which repeat or progress, we see that either you add a fixed number or multiply a fixed number. Okay, this is the two things which we see most of them, right? So if you see the example, this is I am multiplying 1 by 4 every time, correct? This is I am adding 500 every time. Okay, this is 1 square, 2 square, 3 square. Okay, I'm just squaring every number. Okay, every natural number I'm squaring. So like this. So most of the progressions are either adding a fixed number or multiplying a fixed number. Okay, in this chapter we will discuss some of the patterns which succeeding terms are obtained by adding a fixed number on the preceding term or multiplying. Okay, so in these progressions we will learn mainly two progressions. One is a progression which we can be obtained by adding a fixed number, and another progression which a number can be a term or number can be obtained by multiplying a fixed number with the previous term. Okay, so just a small history. The evidence is found that by 400 BCE, Babylonians knew arithmetic and geometric progressions. Okay, so it is not a new technology or new mathematics. This is known by 400 BCE. Okay, according to Boethius 570 CE, these progressions were known to early Greek writers also. Okay, among the Indian mathematicians, Aryabhatta at around 470 CE was the first to give formula for the sum of squares and cubes of natural numbers in the famous book Aryabhattayam, written around 499 CE. Okay, so he is a most famous mathematician from India who invented zero, actually, who gave a symbol to zero and use of zero, who is the one invented. So he also gave a formula for sum of squares and cubes of natural numbers in his famous work. Okay, the book is Aryabhattayam. Okay, he also gave formula for finding sum of n terms of arithmetic progression starting with pth term. Okay, so you take a series of numbers from number x, term x to term y, you can actually sum up. He gave a formula for that. Okay, and another Indian mathematician Brahmagupta, okay, in 598 CE, and Mahavira Bhaskaracharya, okay, they also gave sum of squares and cubes also considered. Okay, so this is the history about the progression. So it is as old as 400 BCE. Okay, so that means they are observing the nature very well and try to formulate the nature's progressions or series patterns. Okay, now let's see arithmetic progressions. Okay, consider the following list: 1 2 3 4 and so on. Okay, 100, 70, 40, 10 and so on, -3, -2, -1, 0 and so on, 3 3 3 3 and so on. Okay, then -1.0, -1.5, -2.0, -2.5 and so on. Okay, in this one each number is called a term. This is the term. Okay, this is the term, second term, this is the third term. Okay, this is a fourth term. Okay, this is the fourth term. Each one is called a term. Okay, so now let's learn the terminology for the arithmetic progression first. Okay, can you write the next term in this? Looking at the pattern here, yeah, it looks easy, right? There is always 1 2 3 4, means it is just progressing by adding 1 to the previous number. So obviously the next number will be 5, 6 and so on, right? And here if you observe carefully, I am subtracting 30 from previous number to get the current number. That is 100 minus 30 is 70, 70 minus 30 is 40, 40 minus 30 is 10, 10 minus 30 is minus 20. So next term will be minus 20. Okay, and here it is minus addition of 1 basically. Okay, minus 3 plus 1, minus 2 plus 1, okay, minus 1 plus plus 1, okay, and then you will get plus 1 here, 2 here, next, and so on. Okay, and in this series there is no change in number, so obviously the next all numbers also will be, next terms also will be 3 3 3 3. Okay, and here it is zero point 0.5 minus 0.5 is the addition. Okay, so the next number term will be minus 3.0, then minus 3.5, and so on. Okay, okay, so in the list, all these lists of number series, whatever is mentioned here, they are in arithmetic progression. Okay, which means we can observe that successive terms are obtained by adding or subtracting a fixed number from the preceding numbers. Okay, this is the key. If you can obtain the successive number by adding or subtracting a fixed number from the preceding number, then such numbers are called, they form arithmetic progression. Okay, this is the definition of arithmetic progression. In arithmetic progression, the next number is formed by adding something to the previous number. Okay, a fixed number basically. Okay, same, or subtracting. We are adding here, we are subtracting here. Here also we are adding 0 actually, right, or subtracting 0. Okay, in the three cases. Okay, so this is the definition of arithmetic progression. Okay, let's try these examples now. Okay, let's check the try this section. Which of these are arithmetic progressions and why? Okay, so the first one is 2, 3, 5, 7, 8, 10, 15. Okay, as far as we learnt so far, the arithmetic progression, okay, you will get the successive number by adding something to the previous. Okay, it's a fixed number. This should be that addition or subtraction should be common across all the terms of the arithmetic progression. So if you see here, 2 and 3 successive numbers, so I have to add 1 to 2, right? So 2 plus 1 is 3. So plus 1 is the a fixed number which I am adding, right? So I should add same number to obtain the next. So 3 plus 1 is 4, but the number here is 5, not 4, right? Which means the common difference or the fixed number is not same here. Okay, so this is not a arithmetic progression. This cannot be arithmetic progression because you have a different common fixed differences between the terms. Here it is 1, here it is 2, 2, then again 1 year, 2 year, 5 year. So this cannot be a arithmetic progression. Okay, let's check the next. 2, 5. Okay, that is plus 3, right? 2 plus 3 is 5. Okay, so 5 plus 3 should be the third number, but that is 8. It should be 8, but it is 7. So this is not a in the this is not the correct term here. Okay, 7 plus 3 is 10. That's fine. Okay, but again here 10 plus 2. So this is definitely not in arithmetic progression. Okay, now minus 1, 3, minus 5, minus 7. Okay, minus 1, minus 2 is minus 3. So I should apply same thing here to get the next term. Minus 3 minus 2 is minus 5. Yes, very good. And then minus 5 minus 2 is minus 7. So this is, I am able to obtain the next term by subtracting 2 from the previous term. Okay, so that means this is a proper arithmetic progression. Okay, similarly write 3 more arithmetic progressions. Actually, if you see the mathematics, many things, many examples you can give which are in arithmetic progression. Okay, what are they? All the natural numbers. Let's say example. Okay, 1, 2, 3, 4, 5, 6, 7. It is in natural. It is in arithmetic progression. All the even numbers. Okay, that is 2, 4, 6, 8. Okay, the common difference is 2 here. All the base, odd numbers. Okay, this is 1, 3, 5, 7. Again, difference is 2. Then all the mathematical tables you take, let's say 3 table. Okay, 3 table, the final results are 3, 6, 9, 12, 15. Okay, they are also in arithmetic progression. So every table is in arithmetic progression, right? So you can give hundreds of examples actually. This is, I mean, this is a very easy question to answer, right? There are several things which are in arithmetic progression. Okay, now let's define the arithmetic progression. What is an arithmetic progression? Okay, it is a list of numbers in which each term except the first term is obtained by adding a fixed number to the preceding number. This is what we are trying to explain using the examples above, right? You should be able to obtain the number by adding a fixed number to the preceding number except for the first number. First number is, yeah, we have some first number, and then after that you should add a fixed number to the each term to get the next number. Okay, this fixed number is called common difference. Okay, common difference of two consecutive numbers, right? So this is a fixed number. This cannot change for a given arithmetic progression. Okay, for a given arithmetic progression it cannot change. Example is here, see, you can see, right? -1, -3, -5, -7. Everywhere difference is -2. Difference is -2. Difference is -2. Right? It should be like that. Okay. So let us denote the first term of a arithmetic progression by A1. Okay. Second term by A2. And nth term by AN. Okay. Then the common difference is denoted by D. Okay. Then we can write the arithmetic progression A1, A2, A3, AN. Okay, and the difference of consecutive terms is always D. A2 minus A1 equal to D, A3 minus A2, and so on up to AN minus AN minus 1 is equal to D. This is the most important rule to obtain a to check if a given the series is in arithmetic progression or not. Okay. Common difference. This is the most important point. Okay. Let us see some examples of arithmetic progression. AP. Heights of students in a school standing in a queue in the morning assembly are 147, 148, 149 dash 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 up to 157. So clearly we can see the common difference is 1 year, 1 year. So it is going on like that. So this is a arithmetic progression. Okay. The minimum temperatures recorded for a week in the month of January in a city arranged in ascending order like this. Okay, -3.1, -3.0, -2.9, okay, -2.8, -2.7. So everywhere if you see, it is basically addition of 0.1 degrees, correct? Addition of 0.1 degrees is happening. So this is another arithmetic progression. Okay, now the balance money after paying 5% of the total loan of rupees 1000 every month is this one. Okay. Okay, every month I am paying 5% of the total loan. Total loan is 1000 rupees. 5% of this is 50 rupees. So every month I am paying 50 rupees. So the balance is 950 rupees, 900 rupees, 850, 800, so on up to 50. Correct? So this is also arithmetic progression. I am subtracting 50 from previous term, starting from 1000. 1000 is my first, if I say. Cash prizes given in a school to the toppers of classes 1 to 12 are 200, 250, 300, 350, so on up to 750. Okay, that means if you see every class as the class increases, basically class 1 to class 2, I am adding 50 rupees extra. Class 1 student topper will get 200 rupees price, class 2 topper will get 250 rupees, class 3 topper will get 300. So everywhere you have 50 rupees extra, the next class topper is getting. So this is also an arithmetic progression. Okay. Total savings after every month for 10 months, total savings after every month for 10 months when rupees 50 are saved each month are like this. Okay. First month I saved 50 rupees. Next month 50 plus 50, that is 100. Next month total savings are 150, then 200. So every month I'm adding 50 rupees, and along with the previous one, this is what the numbers are. They are in arithmetic progression. If you see, the common difference everywhere is 50, right? So everywhere you have to check the common difference. That is the most important point. Okay, let's think and discuss. They are all in arithmetic progression, which we discussed already. Find the common difference in each pattern. Yes, most of them we discussed. Common difference is here it is 0.1, here it is minus 50, plus 50, plus 50. Okay. Okay, these things you can try. These are very small things. You can try yourself. Okay, then let's get to the general form of arithmetic progression. An AP can be written as a comma a plus d, a plus 2d, a plus 3d. Okay, what is this d here? Means I have a common difference d, right, between two numbers, two consecutive numbers. So I'm just adding to the previous one. First is, if first I take it as a, the next one will be a plus d, and next one will be plus d to the previous number, right? So a plus 2d, a plus 3d, so on. Okay, so this is the very general form of a arithmetic progression. Okay, where a is considered as the first term, d is the common difference. Okay, example is here. Here first term is a is 1. Okay, and common difference is 2 minus 1, or any two consecutive numbers you can take, which is 2 minus 1 is 1, or 5 minus 4, which is also 1. Okay, and if you take this series, a equal to 2. Okay, and the common difference is 8 minus 6, which is 2, right? So like this. And in this activity you can see, if you arrange matchsticks like this and count number of sticks actually. Okay, there are 3, 5, 7. Every time I am adding 2 extra matchsticks to form number of one triangle more basically. Okay. Okay, can you find the common difference in members of the list? Is it a constant? Okay, so if you see here 3, 5, 7, 9, so always plus 2, so it is constant, so it is in arithmetic progression. Yeah, definitely it is in arithmetic progression. Now let's learn about the parameters of arithmetic progression. Okay. Okay, if the series of numbers are finite, if there are only finite number of terms in an arithmetic progression, it is called finite AP. Okay, let's say 7 table up to 10. Okay, 7 table up to 10 terms, that is 7, 14, 21 dash 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 up to 70. There are only 10 terms. This is called finite arithmetic progression. Okay, and there are some series progressions which are infinite, like all natural numbers, all even numbers, all odd numbers. Okay, they are in the infinite arithmetic progression, right? So you have two types of progressions, arithmetic progressions: finite AP or infinite AP. Okay, examples of each one we can write plenty of examples. Okay, I gave you one for the finite. Any table you take, you can say up to 10. The table up to 10 terms is a finite AP, and infinite also so many are there. Okay. Okay, now to know about an arithmetic progression, what is the minimum information that you need? Okay, is it enough to know the first term? If I give you only first term, is it enough to build a arithmetic progression? Definitely no, right? I can start every arithmetic progression with the same number always. Okay, example given here, there is arithmetic progression here starting with 6. There is another arithmetic progression starting with 6 here. Okay, both are arithmetic progression starting with 6, but they are not same, right? That means you need initial number, initial term, that is a, as well as common difference d. Okay, These two are important, are the minimum requirements to write any arithmetic progression. Okay, these are the two things which you require. Okay. Okay, so these are the two parameters which are sufficient for us to complete the arithmetic progression. That is initial term and common difference. These are the two things minimum required. Okay. So if I give you A and D, I can build a arithmetic progression like this. A, okay, initial term is -7, so I'm starting with -7, and D is -2, so I subtract 2 from each term. Okay, -2, -9, -11, -13, like this. Please go on like this. A equal to 1.0, D equal to 0.1, so the arithmetic progression will become 1.0, 1.1, 1.2, 1.3, and so on. Right? So initial term is 0, difference is 3 by 2, so it will become 0, 3 by 2, 3, 9 by 2, 6, like this. Okay, initial term is 2 and difference is 0, so the arithmetic progression is all same terms, basically all 2's, 2, 2, 2, 2, and so on. Okay, if you are given a list of numbers, how can you say whether it is in arithmetic progression or not? Okay, only way is find the common difference, and it should be fixed. It should be same. Common difference between two consecutive numbers should be same, right? That's the only way. So if you see the example here given, 6, 9, 12, 15, I should find all the numbers have same common difference or not. So 9 minus 6 is 3, 12 minus 9 is 3, 15 minus 12 is 3. So this is enough to tell that this series of numbers are in arithmetic progression. Okay. Okay. The second one is here. So here also if you see, the difference is a2 minus a1 is -3, a3 minus a2 is -3. So it is fixed. Common difference is same. So it is in arithmetic progression. So this is enough to tell that if a given set of numbers are in arithmetic progression or not. In general, we can write, okay, a of k plus 1 minus a of k should be d. Okay, for all k greater than or equal to 1, and k belongs to n, natural number. Okay. Okay. Now, so you take any, do this experiment, actually it's very interesting. You take any arithmetic progression, add a fixed number to each and every term of the AP. Okay. Write the resulting numbers. You take all, let's start with all natural numbers, that is 1, 2, 3, 4, 5, 6, dash, dash, dash. You add 1 to each. Okay, each term you will add 1, so it will become 2, 3, 4, 5. You just don't have 1. Okay, but you have 2, 3, 4, 5, 6, 7, dash, 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 dash. Correct? Which means it is in arithmetic progression, but the initial number is different. Okay. Similarly, subtract a fixed number. Obviously, addition or subtraction are same. So if you subtract a fixed number from every term of AP, still the resulting series is in arithmetic progression again. Multiply or divide. Let's try this. Take the natural numbers 1, 2, 3, 4, dash, dash, dash. Multiply with 2. What happens? Then result you will get is 2, 4, 6, 8. Okay, which is the even numbers, right? Series of even numbers, which is again in arithmetic progression. Okay. Now, so from this experiment, we understood that you add or subtract, multiply or divide a fixed number to each term of AP, the resulting numbers are still in arithmetic progression. Okay. That's the conclusion we made. Okay. So let's see some more examples here. Okay. The AP is given here. Write the first term and common difference. That's all we have to do. Okay. First term is 1 by 4 here, right? And the common difference is -1 by 4, -1 by 4, which is -1 by 2. If you know that given series is already in AP, you don't need to verify. You just take any two consecutive numbers and subtract, you will get the common difference. You don't need to try all. If they are asking you to verify if given numbers are in arithmetic progression or not, then you have to try all. Okay, the common difference of all should be same. Okay, next example, which of the following forms on AP? Okay, if they form on AP, then write the next two terms. Okay, let's see. 4, 6, 16, 22. Okay, the common difference is 10 minus 4, 6, 16 minus 10, 6, 22 minus 16, 6. So common difference is 6 for all, which means it is in arithmetic progression. And the next two terms are basically 22 plus 6, that is 28, correct? And 28 plus 6, 34. So 28 and 34. Okay. Similarly, 1 minus 1 minus 3 minus 5. So the common difference is minus 2. 1 minus 2 is minus 1. Minus 1 minus 2 is minus 3. Minus 3 minus 2 is minus 5. So this is in arithmetic progression. Next two terms are minus 7 minus 9. Okay. Similarly, minus 2 to minus 2 to minus 2. Okay. Here you see the common difference between these two is 2 minus of minus 2, which is 4. Okay, plus 4 I am doing, but here I am doing minus 4. Okay, 2 minus 4 is minus 2, correct? So common difference is minus 4. So this is not in arithmetic progression, definitely, right? This is not in arithmetic progression. Here 1 1 1 2 2 2 3 3 3, definitely not. There is 0 common difference here, 0 common difference here, there is 1 common difference here, right? So there are different common difference. So it is not in arithmetic progression. X, 2x, 3x, 4x. Yeah, definitely. This is basically you have a natural numbers 1, 2, 3, 4, and you are multiplying with x. So you got 1x, 2x, 3x, 4x. Of course, difference is only x. Okay, so it is in arithmetic progression. Okay, so this is how you should find if the given set of numbers are in arithmetic progression or not. Okay, now let's do the exercise part. Let's do the exercise 6.1. Which of the following situations the list of numbers involved form an arithmetic progression and why? Okay, so there are multiple questions in this. The first one is the minimum taxi fare is 20 rupees for the first kilometer and thereafter rupees 8 for each additional kilometer. Okay, so we know that if you make a series of this information, it will become first is 20 rupees and then 8 rupees addition for each additional kilometer. So 20, 28, 36, 44, like this it will go. So if you look at the common difference, first term is equal to 20, a is 20, and the common difference is always 8, correct? So this is in arithmetic progression. So this is the template for all these questions actually here in the first section. You need to find out the series first, then find the common difference, and if it is constant, then it is in arithmetic progression. Okay. The amount of air present in a cylinder when vacuum pump removes 1/4 of air remaining in the cylinder at a time. Okay, so there is some amount of air in the cylinder, and every time you remove the vacuum pump removes 1/4 of the air every time. 1/4 of the remaining air basically. Okay, so initial air in the cylinder is 64. Let it be. Okay, then we'll just make a table to easily explain the problem. So initial it is 64. Okay, and then 1/4 is removed, that is 16 is removed, right? 1/4 of 64, that is 16. So remaining is 48. Okay, now from 48 1/4 is again removed, which is 12. If I remove 12, then it will be 36. Okay, from 36 1/4 is removed, that is 9. Okay, then remaining is 27. So if you see here, the common difference is this one, 16, 12, 9. This is the common difference, which is not constant, right? If you form the series 64, 48, 36, 27, this is the series. Common difference is 16, 12, and 9, which is different actually. All right, so that means this is not in arithmetic progression. Okay, next. The cost of digging a well after every meter of digging, when it costs 150 for the first meter and rise by 50 rupees 50 for each subsequent meter. This is same as the taxi problem there actually. Okay. So cost of digging the well for the first kilometer is 150. Cost of subsequent meters is 20. 200, 200 comma 250 comma 300. Okay, because 50 rupees addition, right? So the series is 150, 200, 250, 300. Okay, it goes like this. So first term is 150 and the common difference is 50, right? So this is in arithmetic progression. Okay. The amount of money in the account at the end of the year when rupees 10,000 is deposited at compound interest, okay, at 8% per annum. Okay. So this is P equal to 10,000 rupees principal and the compound interest rate is 8%. So amount of money at the end of first year is, you will apply the compound interest formula here, right? P into 1 plus R by 100 whole power n. So after first year, so it is 10,800 and after second year it is 11,664. After third year it will be 12,597. Okay. Now the difference is, first time it is 800, then it is 864. Okay, so both are different. Since the common difference is d is different for this numbers, this series, they are not in arithmetic progression. Okay. Next. Okay, second question. Write down the four terms of AP when the first term A and common difference D are given as follows. Okay, let's see. Okay, first four terms are written as A plus D, A plus 2D, A plus 3D. This is what the first four terms of a AP, where A is the initial first term and D is the common difference, right? So just follow the template, you will get the answers. So you can see each one. Okay, here common difference is D equal to 0, so number remains the same. Okay. 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 So this is the template and you just follow the same for all these problems. Okay. Next. For the following APs, write the first term and common difference. Okay. This is very simple. What is the first term here? Of course, we can see clearly it is 3. Correct? A equal to 3. Common difference is, it is given that they are already in AP. So you just take any two consecutive numbers and find the common difference. Okay. I took the second one and first one, that is 1 minus 3, which is minus 2. Minus 2 is the common difference D. Okay. So same way, just follow the same template for other problems also in this. Okay. Next. Which of the following are APs? Okay. Here they are asking, they are given a series of numbers. We have to find out which of them are APs. That means you have to find out all common differences. Okay. If they form an AP, then find the common difference and next three terms. Okay. Right. 2, 4, 8, 16. Okay. Now the common difference is, first 2 is 4 minus 2, which is 2. 8 minus 4 is 4. 16 minus 8, 8. Okay. So they definitely don't form an AP because common difference is different, not constant. Okay. 2, 5 by 2, 3, 7 by 2, etc. So common difference of all, 5 by 2 minus 2 is 1 by 2. 3 minus 5 by 2 is 1 by 2. 7 by 2 minus 3 is 1 by 2. So here the common difference is constant, which means they form an AP. Okay. And here the common difference is 1 by 2. So you add to the 7 by 2 to get the next numbers. So next three numbers are 4, 9 by 2 and 5. How do you get? Just add 1 by 2 to the previous number. Okay. So this is the same template we will follow for all these questions under 4. Okay. Okay. 3, same thing, you will follow same. Okay. 4. The common difference is not same in this case, in this case. So minus 10, 6, minus 2.2, common difference is not same. So it is not in arithmetic progression. Okay. Next. Okay, they give some surds also. So everything is same. You have to check all the common difference and make sure that they are same or different. Okay, here all the common difference is square root of 2, square root of 2 and square root of 2 for three of them. So they form an arithmetic progression with a common difference of square root of 2. Okay, so the next three terms are basically 3 plus 3 square root of 2 plus square root of 2, which is 3 plus 4 square root of 2, 3 plus 5 square root of 2 and 3 plus 6 square root of 2. These are the next three terms. Okay, now the sixth one is 0.2, 0.22, 0.222 and 0.2222. Okay, if it goes like this, definitely we know that the common difference is not same, which means they are not in arithmetic progression. Okay, same thing you'll check. Okay, if the common difference is same, you can find the next three terms, otherwise no. Okay, so in this case common differences we can clearly see it is 0 because terms are same, all the terms are same. So next three terms also will be same. Okay, 1397, 13927. So here definitely we can see common difference is not same, right? So they are not in AP. Okay, they are not in AP. Okay, A, 2A, 3A, 4A. Yeah, you can see the common difference is A for each of them. Okay, so that means they form an AP. So next three terms are 5A, 6A and 7A. Okay, next A square, A cube and A power 4. Yeah, here the common difference is not same. First one is A into A minus 1, second one is A square into A minus 1. Okay, so definitely not. So they don't form an arithmetic progression. Okay, more questions? Yeah, find out the same way. You can write 8 as 2 square root of 2, 3 square root of 2 and 4 square root of 2. So definitely we can clearly see the common difference is same, square root of 2, right? And thus they form an arithmetic progression. Next three terms are basically 5 square root of 2, 6 square root of 2 and 7 square root of 2, right? Okay. Here there is a mistake. There is no 4 here. This 4 doesn't exist. Okay. So square root of 50, 72, square root of 72 and square root of 98. Okay. Yeah. The next one is the common difference is different, so they don't form an AP. Okay. So we now till now in the previous exercise we learned that how to form an arithmetic progression, how to check if the given series is arithmetic progression or not, common difference, and also we are able to write the next few terms of the arithmetic progression. Let's learn the nth term of the arithmetic progression. How to generalize, give a formula to the nth term of the arithmetic progression. Okay, once you have the formula, then we can find any term, right? So that is the importance of the finding nth term of an arithmetic progression. Let's learn this one. Okay, let's learn the nth term of the arithmetic progression. Okay, how to find the nth term in a arithmetic progression? We have to derive a formula for the nth term basically. Okay, let's learn it through an example. Usha, who applied for a job and got selected, let us consider the offer made to her. Okay, she has been offered a starting monthly salary of 8,000 rupees with an annual increment of 500. We have seen this example before. What would be her monthly salary in fifth year? Okay, so how do you do this? We know that her monthly salary in the second year, beginning of second year, is 8,000 plus 500 because every year 5,000 increment is there, 8,500. Similarly, we know that it will increment by 500 rupees every year, right? At the beginning of every year. So for the third year, it will be 9,000 rupees. That is, you can call it as 2 into 500, right? Okay, or 3 minus 1 into 500 because third year we want to derive the same number uh, as same as the term basically. Okay, so third term 3 minus 1 into 500. Fourth year, okay, 4 minus 1, 4 minus 1 into 500 plus 8000, okay, 9500. Fifth year, 8000 plus 5 minus 1 into 500, which is 10,000, right? This is how we do, right? So we generalized here for given term, okay, the given term, okay, then term is equal to initial value, that is a, plus the term, number of term, that is fifth year, so 5 minus 1 into 500, that is common difference. 500 is common difference, correct? So this is how we can derive a equation for the arithmetic progression nth term, okay? So once you know that, it is very easy to find out for any year. Basically, let's say salary for the 15th year you want to find out, okay? So salary for the 14th year plus 500, correct? So finally it will become 15th term, right? 15th term will become 8000, that is initial salary, plus 15 minus 1 into 500, that is the common difference, which is equal to 15,000, okay? So once you know that, you have a formula, you can calculate nth term of any term basically, okay? So if a1, a2, a3 are in AP, whose first term is a1, and first term a1 is a and common difference is d, okay, then the second term will become a plus 2 minus 1 into d, okay? Third term will become a plus 3 minus 1 into d. This is second term, this is third term, this is fourth term, right? So similarly nth term will become a plus n minus 1 into d, correct? So this is the equation. This is what we want to derive, nth term basically. Now if I substitute n with any number, I can get the value of that, right? I know the initial value, I know the common difference. So any number, 100th term is basically a plus 100 minus 1, that is 99d, right? So nth term of the AP with first term a and common difference d is given by this equation, a of n equal to a plus n minus 1 into d, okay? This is also called general term of the AP, because n you can replace with 1 also, right? For a equal to 1, n equal to 1, a1 equal to a, basically 1 minus 1 is 0, it is equal to a. So this is the general term of the arithmetic progression, okay? And a of m, sometimes they represent with the last term, or they will denote it by L as the last term of the AP, okay? So let's see some examples basically, okay? Find the 10th term of AP, 5, 1, minus 3, minus 7, okay? So here if you see a equal to 5, d equal to 1 minus 5, which is minus 4, and n is 10 is what we need, okay? 10th term, right? After, so n equal to 10. So a of n equal to a plus n minus 1 into d, we know this equation, nth term general equation. So a10 equal to 5 plus 10 minus 1 into minus 4, okay? So that is 5 minus 36 is equal to minus 31, okay? So this is how we will find the nth term of a given arithmetic progression, okay? So the next example, 21, 18, 15, this is the arithmetic progression up to minus 81. Which term is minus 81? That's the question, okay? So this is the arithmetic progression, 21, 18, 15. We need to find where minus 81 comes, which term is the minus 81, okay? So a equal to 21, we know, d equal to minus 3, okay? D equal to minus 3, and a of n equal to already given 81. We need to find out where minus 81, which term is minus 81. We need to find n basically, okay? So a of n equal to a plus n minus 1 into d. So we substitute the given values. A of n is minus 81 equal to 21 plus n minus 1 into minus 3. If you simplify this, what you will get is n equal to 35. So we know that 35th term is minus 81. So once the term value is given, you can find out which term it is, okay? That is also can be done, okay? Okay, and we can also find out like which term is 0. If it is asked, this is equal to 0, we'll substitute and we'll get the same n equal to 8. Eighth term is 0. Okay. Next. Yeah, next example. Determine the AP whose third term is 5 and seventh term is 9. Okay, they did not give initial term, they did not give common difference, but they gave these two. Okay, so now we know that third term is 5. So A3 equal to 5. A3 is nothing but A plus 3 minus 1 into D. That is A plus 2D equal to 5. This is one equation. Seventh term is 9. Okay, which means A7 equal to A plus 6D. Right, A plus 6D equal to 9. Now you have two equations, linear equations in two variable. You know how to solve that. You subtract one from other. 2 minus 1 if you do, what you will get is 4D equal to 4 or D equal to 1 you will get. Okay, and you substitute D value here, you get A value, which is A equal to 3. Okay, so the once you know that A and D, we can write the series. AP has 3 as initial value and D is equal to 1. So it is 3, 4, 5, 6, 7 dash dash dash, like this it will go. Okay, next. Check whether 301 is a term of the list of numbers 5, 11, 17, 23. Okay, if this is in AP, okay, he is asking whether 301 is part of this progression or not. Okay, so first let us check if it is in AP or not. Okay, A2 minus A1 equal to 6, A3 minus A2 also 6. Okay, A4 minus A3 also 6. That means common difference is 6. Okay, which is constant. So they are in AP. Okay, arithmetic progression. Okay, now the AP we have A equal to 5 and D equal to 6. Correct? First term is 5 and D equal to 6. Okay, now AN equal to 301 or not, that we need to find out. Okay, so 301, A of n equal to A plus n minus 1 into D. So 301 equal to 5 plus n minus 1 into 6. Okay, if you simplify, what you will get is n is equal to 151 by 3. Okay, now this is not a positive integer, right? This will become something like 50.3 something, right? But you cannot have a fractional term in arithmetic progression, right? You have all the terms are integer. Okay, which means this 301 is not part of this progression, arithmetic progression. Okay, so 300 not a term of the given list of numbers. Okay, now next example. How many two-digit numbers are divisible by 3? Okay, these kind of questions also can be solved using this nth term and arithmetic progression problems. Okay, list of two-digit numbers divisible by 3. Okay, they starts from 12, right? 12 is the first two-digit number divisible by 3. So 12, 15, 18, the series goes like this up to 99. Correct? So we need to find out how many such numbers are there. Okay, n, what is the value of n we want to know. Okay, so 12 is A equal to 12 initial value, A n equal to nth term is 99. Okay, and common difference is 3, we know because it is a 3 table, right? Now I need to find the value of n. So that's simple again. A of n equal to A plus n minus 1 into D. Okay, so 99 equal to 12 plus n minus 1 into D. D is 3 basically. So if you simplify, the value I get for n is 30. Okay, so that means 30 terms are there in this arithmetic progression. That means there are 30 two-digit numbers which are divisible by 3. Okay, so these kind of problems also we can solve using arithmetic progression. Okay, next. Yeah, more examples, more different kinds of problems we want to see here. Okay, find the 11th term from the last of AP series given below. Okay, 11th term from the last of AP we need to find out. Okay, so the series given is 10, 7, 4 dash 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 up to minus 62. Okay, last A of n is minus 62. Okay, so here A equal to 10, D equal to 7 minus 10, which is minus 3. L is last term is minus 62. Okay, so L equal to A plus n minus 1 into D. Okay, so we want to first find out how many terms are there. Once you know the n, you can read from any side you want, right? Okay, So minus 62 equal to 10 plus n minus 1 into minus 3. If you simplify, what you will get is n is 25. That means there are 25 terms in the given AP. Correct? There are 25 terms in the AP. Okay. So the question asked is 11th term from the last. Okay. So 11th from the last is basically 15th of the AP. Okay. 25 minus 10 is what you have to do. Okay. So 15th term is basically, if you substitute the values, 10 plus 15 minus 1 into minus 3, that is minus 32. Okay, so the 11th term from the end is minus 32. This is how we can do. Okay. Alternatively, we can solve it other way. When the exercise comes, I will show you the alternate way. You can, if you read this, you can also do the alternate way. Okay. A sum of 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. Do this interest form an AP? First thing. If so, find the interest at the end of 30 years. Okay. So the question is, we know the simple interest rate, that is PRT by 100. Okay. Principal is 1000 rupees. R is 8%. T is time. Okay. So at the end of first year, interest is 80. End of second year, interest is 180. Okay. End of third year, interest is 240. Okay. Now let's form a series like this. Okay. 80, 160, 240. These numbers will be in arithmetic progression or not. Let's check. Common difference of all the each one is basically 80. 160 minus 80 is 80. 240 minus 160 is 80. So common difference is 80. So it forms an arithmetic progression and A equal to 80. Now the question asked is the interest at the end of 30 years. Okay, so simple. Okay, A of 30 equal to A plus 30 minus 1 into D, that is 80 plus 29 into 80, that is equal to 2400. This is the interest at the end of 30 years. Okay, another kind of example. In a flower bed, there are 23 rose plants in the first row. Okay, 21 in the second row, 19 in the third row. So each row there are basically 2 less. Okay, there are 5 rose plants in the last row. How many rows are there in the flower bed? Okay, so this is simple. So the AP is basically 23, 21, 19 dash 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 up to 5. 5 is the last one. Right, now we need to find out number of terms. Basically number of rows is equal to number of terms, right? So I know A equal to 63, D is equal to 21 minus 23, A is equal to 23, D is equal to 21 minus 23, which is minus 2. Okay, and A of n, last term is 5. Okay, so A of n equal to A plus n minus 1 into 2. This is the only equation we are using so far. Okay, equal to, okay, 5 equal to 23 plus n minus 1 into minus 2. If you simplify, what you will get is n equal to 10. That means there are 10 rows in this flower bed. Okay, now let's do the exercise 6.2. Okay, let's do the exercise 6.2. Fill in the blanks in the following table. Given that A is the first term, D is the common difference, An is the nth term of the AP. Okay, so the table is given like this with 4 columns basically, A, D, N and An. Okay, the last term basically. Each row, one of the values missing. Okay, we need to fill that value. Okay, so now let us write the equation which we know, nth term equation. Okay, that is A of n equal to A plus n minus 1 into D. We know this. So from this we derive each formula for each of them. D is equal to an minus A divided by n minus 1. Okay, A equal to an minus n minus 1 into D. N equal to an minus A by D divided by D plus 1. Okay, these 4 equations, if you write it here, then we can calculate the values very easily. Okay, let's complete this table. Okay, so I wrote the formula for each of the values here. Now in the first row, if you see, the missing value is an. Okay, an is nothing but A plus n minus 1 into D. So I just substitute all the values. 7 plus 8 minus 1 into D, which is equal to 28. Okay, Similarly, you can solve for rest all. These are the formulas to use here. Okay. Hope you can do it yourself. This is very simple. Next. Second, find the 30th term in the AP of 10, 7, 4 dash dash dash. Okay. So A equal to 10, D is equal to, it's mentioned already that it is a AP, okay, arithmetic progression. So we don't need to verify whether it is in AP or not. You just take common difference by subtracting any consecutive numbers, terms. So D is equal to 7 minus 10 equal to minus 3, N is equal to 30. 30th term is what we need, okay. So AN equal to A30, A30 equal to A plus N minus 1 into D, or 10 plus 29 into minus 3, which is equal to minus 77. This is the value. So this is the template. We can use same template and to solve all the values what we want. Okay. 11th term of the AP, same way. A is minus 3 and D is 5 by 2, N is 11. So you'll get 22 as the value. Next. A1 is given, A3 is given, find A2. Okay. So one thing is very easy way to do is in arithmetic progression always middle term is always average of the neighboring terms. Okay, A2 is average of A1 and A3. Okay, A3 is average of A2 and A4, like that. So that way it is easy to find A2 is equal to A1 plus A3 by 2. But let's just follow the same way how we are solving the other problems, because we have a template fixed here, right? So A3 equal to A1 plus 3 minus 1 into D, okay, which is equal to 26 equal to 2 plus 2D, or D equal to 12. Once you know the D, A2 equal to 14. Okay. If you do average, 26 plus 2 is 28, 28 by 2 is 14, same value. Alright. Okay. Next. Okay. So this is the alternate way. Okay. A2 and A4 are given, A1 and A3 we need to find out. A3 is simple, average of A2 and A4, okay, which is 8, and A is equal to D is equal to A3 minus A2, okay, difference between two terms, right, two consecutive terms. So 8 minus 13, okay, 8 minus 13, which is minus 5, okay. And A1, oh, okay, they asked A1 actually, not common difference, they didn't ask. Okay, A1 equal to A2 minus D, okay, which is equal to 13 minus of minus 5, which is equal to 18. Next. A1 equal to 5, A4 equal to 9 and a half, find A2 and A3, same way, okay, follow the template. A1 is given, A6 is given, we need to find out A2, A3, A4, A5, okay. Simple, first find out the D, okay, once you D is equal to 2, once you know the D and A1 is already known, so any number you can find out. A2 is given, A6 is given, okay, find A1, A3, A4, A5, okay, same way. A1 plus 5D is A6, A2 is equal to A plus D, okay, these two values are given, okay, so A6 minus A2 equal to 5D minus D, which is 4D equal to minus 22 minus 38, okay, so that is D is equal to minus 15. Once we know the D, then we can find out all the values. Next. Which term of AP, okay, the AP is given 3, 8, 13, 18, dash 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 is 78. We need to find out that, okay. So given that A1 equal to 3, A2 equal to 8. So D is equal to 5, right? 8 minus 3 is 5. So 78 equal to 3 plus n minus 1 into 5, okay. If you simplify, what you will get is n equal to 16. So 16th term is 78. Okay, next. Find the number of terms in each of the following APs. Okay. 7, 13, 19, dash dash dash. 205. Okay, we need to find the number of terms, that is n value we need to find out. Okay, d is equal to 6, 13 minus 7. Okay, so 205 equal to 7 plus n minus 1 into 6, which means n equal to 34. Okay, there are 34 terms in this AP. Okay, similarly, next problem, same template you can follow. You will get n equal to 27. Next. Okay, check whether minus 150 is a term in the AP. 11, 8, 5, 2. Okay, we can see the common difference is 3. Okay, minus 3, sorry. A1 equal to 11, D is equal to 8 minus 11, which is minus 3. So A of n equal to, this is the equation which we know. So minus 150 equal to 11 minus 3 into n minus 1. Okay, if you do the calculation, what you will get is, you don't get a integer value for n. N is equal to 161 divided by 3 plus 1. Okay, so 161 cannot be divided by 3, which means you don't get a integer value for n. So that means minus 150 is not a term in the arithmetic progression. Next, find the 31st term of the AP whose 11th term is 38, 16th term is 73. So you just write A11 equal to 73, A11 equal to 38, A16 equal to 73. So you get two equations, A1 plus 10D equal to 38, A1 plus 15D equal to 73. Subtract both of them, what you will get is 5D equal to 35 or D equal to 7. Once you know the D, you can get anything, right, out of it. We need 31st term basically, right? So A11, if you substitute D value, you get the A1 value. So A11 equal to A1 plus 11 minus 1 into D. You substitute the value, then you get the A1 value. A1 is nothing but minus 32. Okay, so A31 equal to A1 plus 30D, which is 178. Next. Yeah, just cross check this one. D is equal to 7. Yeah, I think, yeah, that's fine. Next. If the third and ninth terms of AP are 4 and minus 8 respectively, which term is some value is 0 basically. Okay, which term is 0. So given that A3 is 4, A9 is 8. So again you get two equations. A1 plus 2D equal to 4 and A1 plus 8D equal to minus 8. Subtract, what you will get is D equal to minus 2. Once you know D, then you can calculate A1 value. A1 is 8. Okay, so 0 we are trying to find out which number. So 0 equal to 8 plus n minus 1 into minus 2. So n is equal to 5. Okay, so fifth term is 0. Next, the 17th term of AP exceeds its 10th term by 7. Find the common difference. Okay, so first is A17 minus A10 is equal to 7. This is what is given. So you expand it. A17 is A1 plus 16D. A10 is A1 plus 9D. Okay, subtract both the equations. What you will get is A17 minus A10, which is equal to 7D equal to 7. So D is equal to 1. That means common difference is 1. Next, two APs have same common difference. Okay, the difference between the 100th term is 100. What is the difference between the 1000th term? Okay, so there are two APs. Okay, common difference is D only for both of them. Okay, let's say 100th term of first series is A of 100 equal to A1 plus 99D. Okay, 100th term of second series is B100 equal to B1 plus 99D. D is same. Okay, now is telling B100 minus A100 is equal to 100. Okay, so which is B1 minus A1 equal to 100. Okay, now 1000th term is A1000 equal to A1 plus 999D, B1000 equal to B1 plus 999B, D. So B1000 minus A1000 equal to B1 minus A1, again same, right, which is equal to 100. We already know. So that is also 100. Difference in every term, basically every uh, relative term between the two APs is same, because common difference is same. Next, how many three-digit numbers are divisible by 7? Okay, so he's asking how many three-digit numbers. Okay, so first three-digit number divisible by 7 is 105. This is the first thing. So A equal to 105. Okay, and we need to find out common difference is 7. Okay, we need to find out how many n, basically value of n. Okay, uh, we need to find out. Okay, so maximum value of the three-digit number cannot be more than 999. So what I am writing is 105 plus n minus 1 into 7 is less than 1000. It should be less than 1000. Okay, which means 7 into n minus 1 equal to, or it should be less than 1000. 1000 minus 105, which is 895. Okay, so n minus 1 should be less than 895 by 7. Okay, or n is less than 895 by 7 plus 1, which is equal to 902 by 7 or 128 6 by 7. Okay, it should be, n should be less than this value. What is that integer value which is less than this? That is 128. Okay, so n is equal to 128, which means there are 128 three-digit numbers which are divisible by 7. Okay, next, how many multiples of 4 lie between 10 and 250? Same problem. Okay, uh, first multiple after 10 is 12, which is the multiple of 4 basically, and the first term of the progression equal to a1 equal to 12. Common difference is 4. Last term is obviously 248. We can see easy. The last term is given, maximum is 250. So 248 is divisible by 4. Now we just need to find out how many multiples, right? N value we need to find out. So 248 equal to 12 plus n minus 1 into 4, or n is equal to 60. There are 60 multiples lie between, 4 multiples lie between 10 and 250. Next. Okay, so for what values of n are the nth terms of two APs, which is given here, are equal. Okay, so first progression, first term of the progression a1 equal to 63, common difference is 2. Okay, so for the second progression, first term b1 equal to 3 and d2 equal to 7. Okay, now nth terms of both progressions are equal, so write both of them. 63 plus 2 into n minus 1 equal to 3 plus 7 into n minus 1. So this is the equation which you will get if you simplify and solve it. Solve for n, you get n is equal to 13. That means 13th terms of both progressions are same. Okay, okay, there is another type of question given here. Determine the AP whose third term is 16 and seventh term exceeds the fifth term by some value which is given, right? So third term is a3 equal to a1 plus 2d equal to 16. Okay, and seventh term minus fifth term is 12. Okay, so that is a plus 60 minus a1 a plus 4d equal to 12, or 2d equal to 12, or d equal to 6. So now we got it. You have a, correct. We can derive a now from this equation. A1 plus 2d equal to 16, we can derive a with the d equal to 6, right? So a1 is 4, d equal to 6. Now the arithmetic progression is 4, 10, 16, 22, dash, dash, dash. Okay, we can construct the arithmetic progression with a and d. Now find the 20th term from the end of AP given here. A1 equal to 3, d equal to 8 minus 3, which is 5. So 253 is the last term. So from that we can calculate n value. N is basically 51. Okay, so there are 51 terms in the progression. 20th term from end is 51 minus 19, which is 32. Correct. So 32nd term is equal to 158. Alternatively, we construct a AP with you reverse basically. Okay, I assume that 253 is the first term. Okay, and D is equal to, instead of 5 it will become -5 because it is in decreasing now. And the 20th term is what we need to find, because we are finding 20th term from the end of the original AP, right? 20th term from the end of the original AP. Now if I reverse it, it will come from the beginning, 20th term. So 20th term from the beginning is 253 plus 19 into -5, which is equal to 158. Okay, same. I think this alternate method is easy. You don't get confused, because if you use this, you need to subtract one less than the given number from other end, right? So this method is better. Okay, you reverse the AP and then find out whatever term they want. Okay, next. The sum of 4th and 8th terms of AP is 24, and sum of 6th and sum of 6th and 10th terms is 44. Find the first three terms of the AP. Okay, yeah, this is simple. We know A4, we know A8. Okay, so A4 plus A8 equal to 24. So 2A1 plus 10D equal to 24. Sixth term, 10th term, sum of these two is equal to 44. 2A1 plus 14D equal to 44. Now you E1 and E2, if you call it equation 1 and equation 2, this is sorry. Okay, if you subtract them, what you will get is 4D equal to 20 or D equal to 5. So you have the D, you substitute any of the equations, you get the A1 value. Okay, so A1 equal to -13, D equal to 5. So the progression is, arithmetic progression is -13, -8, -3, comma, dash, dash, dash. First three terms is what they asked, so that's what we wrote here. Next. Subbarao started his job in 1995 at a monthly salary of rupees 5,000 and received an increment of 200 each year. In which year did his salary reach 7,000 rupees? Okay, I think we solved the similar problem in the example. So A1 equal to 5,000, increment, that is common difference, which is equal to D equal to 200. So final salary to reach is nth term, which is 7,000. Okay, so An equal to A1 plus n minus 1 into D. So from this we can find out n is equal to 11. Okay, so in the 11th year his income will reach 7,000 rupees. That's the answer. So from the nth term general formula, so many kinds of different kinds of problems we can solve actually in arithmetic progression. Okay, so now let's learn okay, yeah, let's learn the one more formula which is most important for the arithmetic progression. This is useful for several problems in your future actually. So that is sum of first n terms of the arithmetic progression. Okay, sum of the first n terms of the arithmetic progression. Okay, so if you have arithmetic progression, you have n number of terms in that, then we can, from the formula we can find out, okay, what is the sum of those n terms. If the n is very big number, let's say 10,000, 20,000, 30,000, okay, manual calculation becomes very, very difficult, correct? So you require a formula. That's what we will learn now. Let's learn this how to do the sum of first n terms of arithmetic progression. Okay, so far we learned nth term, how to determine the nth term, and all kinds of problems with respect to nth term, right? Now we will learn how to find out the sum of n terms in arithmetic progression, and let's see all kind of problems with respect to that. Okay, so we consider simple exams. We have a arithmetic series basically, okay, of let's say 1000, 1500, 2000, like this. Okay, right? And then in this series we want to sum up. Okay, so the example given here is Hema has put 1,000 rupees in money box when her daughter is 1 year old. okay, and 1500 on her second birthday, 2000 on her third birthday, and continue like that up to 21 years. How much money will be there in the box? That's the question. Okay, so we know that this is a arithmetic series because starting with 1000 and common difference is 500. Every year she is adding 500 rupees extra, correct? So until 21st year, so how do you do? One way is you write this series up 21 times and then add all of them, correct? So that's the way we can do normally. But let's think that you are doing a series, okay? There is a series where there are 100 terms or 1000 terms are there, and then how do you find the sum of the uh, terms, n terms? Okay, if the n is 100 or 1000, it will be very difficult, correct, to sum up in the normal way. So we need to find a way, we need to find a formula basically, okay, to find out sum of n terms. Okay, so there is a mathematician by name called Frederick Gauss. Okay, he's a German mathematician. Okay, he is the first known person in the modern era. Of course, there are many people who have done before, but we don't have records actually. So he is the first modern mathematician who has done and this work, and he has given an equation for sum of n terms in a arithmetic progression. And what he has done, it is very simple actually. The technique he used is very simple. If you see, you will understand. Oh, this is so simple. Okay, so let's say sum s equal to sum of 100 natural numbers. Okay, 1 to 100, right? This is a arithmetic progression. So I want to add all these arithmetic progression and find out how much is the value. Okay, so this is correct. S equal to 1 plus 2 plus 3 up to 100. Now what he has done is he reversed the numbers. Okay, reversing also will get same, right? So S equal to 100 plus 99 plus 3 plus 2 plus 1 up to 1, correct? Now you add these two equations. Let's consider this as equation 1. Let's consider this as equation 2. Okay, equation 1 is here, equation 2 is here. Okay, if you sum up all this, okay, on the LHS side you will get 2s, s plus s. Okay, and the RHS side each term is 101, correct? 100 plus 1, 99 plus 2, okay, 98 plus 3, like this, right? So on it will go. 3 plus 98, 2 plus 99, and 1 plus 100, correct? So that means there are 101. Each term has become now 2s equal to each term has become 101. How many 101s are there? Obviously we know 100. So this is 100 times 101, correct? And 2s, this is equal to 2s. So s is equal to 100 into 101 divided by 2, okay, which is 5050. The sum is, okay. So this is the simple method he used, and instead of 100 you make it n, okay, up to n. So still it will be, this is the same way we can find out the equation for sum of n terms. Okay, so here is the general method. We know that in an AP the terms are a plus d, a plus 2d, and so on up to nth term, which is a plus n minus 1 into d, correct? So Sn, if you denote this as sum of first n terms of the AP, okay, then it is a plus d, a plus 2d up to a plus n minus 1 into d. This is the last term, right? Same way I will reverse and write it. Sn equal to again a plus n minus 1 into d. This is my first term. This is my second term, a plus n minus 2 into d up to a. Now if I add 2, this will become 2Sn, and each term will become 2a plus n minus 1 into d, correct? 2a plus n minus 1 into d. Okay, how many times? N times. So this is n into 2a plus n minus 1 into d equal to 2Sn. So Sn equal to, this is my equation, final equation, right? This is my final equation. Okay, so sum of n arithmetic progression terms equal to n by 2 into 2a plus n minus 1 into d. Okay, now I can also call this way, n by 2 into a plus, I am separating a plus n minus 1d. This is nothing but last term, correct? This is nothing but last term. A plus n minus 1 into d is the last term, correct? So n by 2 into first term plus last term. This is also another equation. So n by 2 into a plus an, correct? So there are two ways you can find out the sum of n terms. One is n by 2 into 2a plus n minus 1 into d. If you don't know what is the last term and you only know how many terms are there and common difference. Okay, and if you know the last term and first term but you don't know the common difference, you can use this formula. These are the two formulas basically, right? Okay, so now we return to the example and find out for 1000 or 1500, 2000, etc. Okay, so a equal to 1000, d equal to 500 and n equal to 21. Okay, right, starting with the 1000, common difference is 500 and 21 years. After 21 years you want to find out what is the total amount will be. Okay, so s of n equal to n by 2 into 2a plus n minus 1 into d. So if I substitute the values, the answer I will get is 1,26,000. Okay, this is the amount she will have when she reaches 21 years, correct? Okay, so Sn will denote sum of first n terms of AP so that we know how many terms are added. Okay, S20 means sum of 20 terms. Okay, just a notation basically is explaining the notation. S20 means it is sum of first 20 terms. Okay, so this is how it is. Now one more thing you should understand is Sn, this is sum of n terms minus Sn minus 1, okay, which is sum of n minus 1 terms. The difference of these two is the nth term, correct? This is a series of up to an, this is series up to an minus 1. So difference is only an. Okay, so this is one important thing to note down. You can solve several problems using this method. Okay, so note it. Let's do this section. Let's do the do it section. Find the sum of indicated number of terms in each of the following AP. The first one is 16, 11, 6, 23 terms. Okay, so we know a equal to 16 and n equal to 23. Okay, and d equal to 11 minus 16, that is minus 5. Okay, now Sn, okay, that is sum of n terms equal to n by 2 into 2a plus n minus 1 into d. If I substitute all the values, okay, what I will get is minus 897. Okay, this is the answer. Next, so it's the same template which we will use basically. So next series is minus 0.5, minus 1, minus 1.5, 10 terms. Okay, so a equal to minus 0.5, n equal to 10 and d equal to minus 0.5. Okay, so you substitute in Sn equal to n by 2 into 2a plus n minus 1 into d. Okay, what you will get is minus 27.5. Okay, if you simplify, this is the value you will get. Okay, next, find the sum of indicated numbers. The third question is minus 1, 1 by 4, 3 by 2, 10 times, 10 terms basically. Okay, so a equal to minus 1, number of terms is 10. Common difference is minus 1 by 4, minus of minus 1, that is 3 by 4. So now you substitute the values in this, it will become 10 by 2 into minus 2 plus 3 by 4 into 9. So which if you simplify, you will get 23.75. Okay, so these are the do it section. Let's do some more examples and learn how many ways we can use this formula and what are the things we can derive. Okay, if the sum of first 14 terms of AP is 1050 and its first term is 10, find the 20th term. Okay, So this is one kind of question. S of n equal to 1050, n equal to 14, so we can call it S of 14 is 1050. Okay, and a equal to 10. Okay, so if I substitute 1050 equal to 14 by 2 into 2 into 10 plus 13d equal to 140 plus 91d. Okay, so if I simplify it, d equal to 10, this is what we will get. So once I know d and a, okay, I can calculate any term which I want, right? So a20 equal to 200. If I substitute into a plus n minus 1 into d, this is what I'll get. Okay, so this is one way of the using this equation. Okay, next, how many terms of the AP 24, 21, 18 must be taken so that their sum is 78? Okay, basically I want to find out how many terms, number of terms, that is n, I need to find out so that the sum is 78. So now what is the given data? A equal to 24, okay, d equal to 21 minus 24, that is minus 3, and s of n, sum of n terms is 78. So I'll substitute into this standard equation sum of arithmetic terms, n arithmetic terms. So 78 equal to n by 2 into 51 minus 3n, okay, or I will get a quadratic equation, okay, 3n square minus 51n plus 156 equal to 0. This is the quadratic equation I get. Now we know how to solve the quadratic equations, we have learned it. So I get two values for n, okay. Here I have tried a factorization method, okay, n minus 4 into n minus 13 equal to 0, which means n equal to 4 or 13, okay. So is the answer looks anything surprising and strange to you? There are two values of n, that means there are 4 number of terms which will sum up to 78, and also it says 13 terms which will sum up to 78. How is it possible? Just think about it. Okay, okay, so the simple way to understand this one is, first 4 terms if you take, okay, 24, 21, 18 and 15, okay, if you sum up you will get 78 terms, okay, 78. But after that, okay, I also should get up to 13 terms, right? So almost there are 9 terms which are basically summing up to zeros, okay. So that is basically, this is a decreasing progression. So you will get negative terms also which will cancel the positive terms, okay. And these 9 terms basically from 18 onwards you will get up to minus 18 basically, okay, up to minus 18. So everything gets cancelled and you have a 0 also in this, okay. So that's why it is you got the two answers, 4 and 13, okay, both are correct answers. Okay, next example, find the sum of first 1000 natural numbers, first n natural numbers. Okay, this is a general equation. We want to derive a general equation for sum of first n natural numbers. Okay, 1000 is simple. A equal to 1, correct. D equal to 2 minus 1, that is 1 again, and n equal to 1000, right? So if I substitute in this, I don't need D actually, because I know I want to do up to 1000, right? So L I have. Okay, so S of n equal to n by 2 into A plus L, first and last, basically sum of first and last. So that is 1000 by 2 into 1 plus 1000, that is 1001. Okay, so total, this is what the total of first sum of first 1000 natural numbers. Okay, 50 lakhs 500, sorry, 5 lakhs 500. Okay, now we will derive a general equation. Okay, so this is 1 plus 2 plus 3 up to plus n. So first a is 1, correct, and L is n, last number is n. So which means Sn equal to n by 2 into 1 plus n by 2. Okay, that is nothing but, if you write it, this is the sum of first n natural numbers, n into n plus 1 by 2. Okay, so we have to remember this. This is one of the most used equation in maths now onwards. Okay, let's go next. Some more examples we'll see before going into the exercise for arithmetic progression. Find the sum of first 24 terms of the list numbers whose nth term is given by an equal to 3n, 3 plus 2n. Okay, this is the nth term. Nth term is given like this. So let's find first term a1 equal to, you have to replace n with 1, right? So that is 3 plus 2, which is 5. Okay, so we got a1, a2 is 7, a3 is 9. Okay, so this progression goes on like this. Okay, now what we know, this is the progression. Common difference is 2. You take any two numbers, 11 minus 9 equal to 2. Okay, so this is the AP, so a equal to 5 and common difference is 2. So s of 24, we want to 24th term, right? So n equal to sum of 24 numbers. So n equal to 24, a equal to 5, d equal to 2. If I substitute this into the sum of n terms of arithmetic progression equation, 24 by 2 into 2 into 5 plus 24 minus 1 into 2, which is 672. This is the value we'll get. Okay. Now another example. A manufacturer of TV sets produced 600 sets in the first year, 700 sets in the 7th year, 600 sets in the 3rd year, 700 sets in the 7th year. Okay, assuming that the production increases uniformly by a fixed number every year, find production in the first year, production in the 10th year, and the total production in first 7 years. Okay, so what is the information given? 3rd year he produced 600 TVs, that is A3 equal to 600. 7th year he produced 700 TVs, that is A7 equal to 700. Okay, so if I expand, A plus 2D equal to 600, A plus 6D equal to 700. If I subtract them, basically what I will get is, right, 4D equal to 100 or D equal to 25. And if I substitute D equal to 25 here, I will get A equal to 550. Okay, this is the first year production. Correct. So we answered one question. First year production is 550. Now he want to know 10th year production. Correct. In 10th year, A10 equal to A plus 90, which is 550 plus 9 into 25, which is 775. So in the 10th year, he'll produce around 775. Okay. And sum of first 7 years of production, that is S7 equal to 7 by 2 into 2 into 550 plus 7 minus into 25, which is nothing but 4375. So many number of TVs he produced in first 7 years. Okay, so this is another type of problem. Let's see more. Okay, exercise section is there. Now let's do the exercise. Let's do the exercise 6.3. Okay, find the sum of APs, the following APs basically. Okay, 2, 7, 12, 10 terms. So this is very simple. Just fix the template first. Okay, all these problems what you have to do is initial term, which is a equal to 2, number of terms n equal to 10, common difference is 7 minus 2, that is 5. Once you know these three values, you just substitute in the sum of n terms equation. Okay, the answer is 245. Similarly, you can do this for this. Okay, the answer is minus 180 for the second series. Okay. Okay, third series 0.6, 1.7, 2.8, 100 terms. Okay, so a equal to 0.6, n equal to 100, d equal to 1.1. So the answer is 5505. Okay, next 1 by 15, 1 by 12, 1 by 10, 11 terms. Okay, a equal to 1 by 15, n equal to 11, d equal to 1 by 60. If I substitute the values, I get 33 by 20. Okay, next. Okay, find the sum of following APs. Okay, here instead of number of terms, basically what is given is complete series and the last term is given. Okay, So this series has 7, 10 and a half, 14, dash 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 up to 84. Okay, not 84 terms. This is 84 is the last term. Okay, so you have a1 equal to 7. Common difference is you can calculate, which is 7 by 2, and then an equal to we need basically an equal to 84. So from this we can calculate n value. Okay, because without n value in Sn equation you have n by 2, right? So n value is a must. So n is 23. We can calculate from this, and you substitute into the equation. What you will get is 1046 and half. Okay. Similarly, second problem you can do same way. 34 plus 32 up to 10. A1 equal to 34, D equal to minus 2. Okay. Last term is 10. So from this I can derive n value, which is 12, n equal to 12. If I substitute, I get the answer Sn equal to 264. Next. Okay. Other equation is minus 5, minus 8, minus 11 up to minus 230. Okay. So same way, a1 equal to minus 5. Common difference is minus 3. Okay. From the nth term equation, I can get n equal to 75. N equal to 75. So the total is 8812 and half. Okay. The sum of arithmetic progression is 8812 and half. Okay. Third question. Given that a equal to 5, d equal to 3, an, this is a subscript. Okay. N equal to 50. Find n and Sn. Okay. So initial term a1, d, nth term an equal to a1 plus n minus 1 into d. So if I substitute the values, I can get n value, which is 16. Okay. Once I know n value, a1 and d, I can get Sn equal to 440. Okay. So all these problems are almost same. Every time he is giving a different value and try to find out whatever you want basically. Okay. So in this case, a equal to 7, a 13 is given, which is 35. Okay. Instead of an, a 13 is given. Okay. So which is still same, right? A 13 equal to, again you will write same way, a1 plus n minus 1 into d, same equation you will use. Okay. So 35 equal to this one. So I get the d value. D is equal to 2 1 by 3. Okay. Once I know again all these values, I substitute it. I get the sum as 273. Okay. Next. A12 is given, D is given. Okay. And find A and S12. Okay. Here indirectly they gave n also. N is also 12. Correct. Sum of 12 terms and A12 is given. So last term is given basically, and D is given, n is given. Okay. So n is 12, A12 equal to 37, D equal to 3. So nth term again I will use the same equation. Then I get the value of A1 equal to 4. Now I have all the values required. I substitute in the Sn. So the answer is 246. Okay. Now here again, A3 is 15, S10 equal to 125. Find A and A10. Okay. So A3 is 15, S10 is 125. Okay. That means n is equal to 10. So A3, from A3 equal to A1 plus 3 minus 1 into d. From this I get one equation, 15 equal to A plus 2d. And from Sn equation, S10 equal to, from this equation I get second equation. If I substitute all the values, 2a plus 9d equal to 25. Okay. So if I want to eliminate one of the variables, what I will do? 2 into e1 minus e2, which is I get minus 5d equal to 5 or d equal to minus 1. Okay. From this, once I know the d, substitute in this equation. Okay. D value, I get a value also. A is equal to 17. Now I have all the required values. I have A, I have D, I have N, I have everything, right? S also I have. So A10 is what we need to find out. A10 equal to 12. Next. Okay, given a equal to 2, d equal to 8, sn equal to 90, find n and an. Okay, it's almost similar, all the problems are similar. Please go through this step by step. Okay, I think you can solve them very easily. So in this one, the difference is we are forming a quadratic equation. If you substitute the known values, we have a1 which is equal to 2, common difference d equal to 8. So in Sn, if I substitute the value, I get a quadratic equation. Okay, what I know is I don't know n basically. I don't know n here. So a and d values I substitute. So it will become n by 2 into 4 plus n minus 1 into 8, or if I simplify, I get a quadratic equation 8n square minus 4n minus 180 equal to 0. Okay, if I factorize, what I will get is n equal to 5 or 9 by 2. 5 or 9 by 2. And it is very clear, total number of terms cannot be fraction, right? It has to be an integer. So 9 by 2 is not correct. So only possibility is n equal to 5. Once I know n equal to 5, an equal to, I just substitute the values into the equation, I get 34. Okay, same way, an is given, d is given, sn is given, find n and a1. Okay, so an equal to 4, d equal to 2, so n equal to a1 plus n minus 1 into d. If I substitute the values, what I will get is a1 equal to 6 minus 2n, a1 equal to 6 minus 2n. Then Sn equal to n by 2 into a1 plus 4, which is equal to minus 14, which is given. So I get a quadratic equation here, n square minus 5n minus 14 equal to 0, or if I simplify, I get n equal to 7 or minus 2. Now again, number of terms cannot be negative also, right? So minus 2 is not possible. Only valid answer is n equal to 7. Once I know n equal to 7, I can derive a1, which is 6 minus 2n. If I substitute the value 7 here, I get minus 8. Next. The first and last terms of the AP are 17 and 350 respectively. If the common difference is 9, how many terms are there and what is their sum? Okay. A1 equal to 17, an equal to 350, d equal to 9. So just you need to find their an n and sum basically. Okay, so just substitute the values. Okay, you will get n equal to 38 and sn equal to 6973. Okay, so another question, L equal to last term is 28, S9 equal to, that is sum of 9 terms is 144. Okay, so there are total 9 terms which is given, find A1. Okay, which is simple. An equal to 28, Sn equal to n by 2 into A1 plus An. Okay, so that is 9 by 2 into A1 plus 28, which is equal to 144. If I simplify, I get A1 as 4. Okay, next. If the sum of first 7 terms of an AP is 49 and that of 17 terms is 289, find the sum of first n terms. Okay, so S7 is given 49, S17 is given 289. So with this equation, sum of arithmetic progression terms, sum of n terms of arithmetic progression equation, we can form two equations basically in variables a1 and 6d. Okay, first equation is 2a1 plus 6d equal to 14. Okay, from S7 I get, and from S17 I get second equation, that is 2a1 plus 16d equal to 34. Okay, if I subtract both of them, what I will get is d equal to 2, and if I substitute d value in one of the equations, I get a1 as 1. Okay, now once I have all the values, sum of n terms is equal to, if I simplify, I get n square. Okay, this is the general equation. Next, find the sum of first 51 terms of an AP whose second and third terms are 14 and 18 respectively. Okay, so A2 is 14, A3 is 18, and we need to find out Sn, where n is equal to 51. So D equal to A3 minus A2. I don't need to do full equation here. I know that common difference is always uh, difference of the consecutive terms, right? So D equal to A3 minus A2, which is 4. A1 is A2 minus D, we know. So initial term is 10. So now I have all the values required. If I substitute, what I will get is Sn equal to 5610. Okay. So use all these tricks actually to solve all these problems. Okay. In this one, equation is given. Basically, if you see here, an equation is given 9 minus 5n. We need to find out if it forms an AP. If it is forming a AP, then find the first 15 terms, sum of uh, first 15 terms basically. Okay. So for an AP, the common difference should be constant. This is the main point, right? So if I prove that with this equation, an equation, the common difference is constant, then it is forming a AP. Correct? So an equal to 9 minus 5n, an plus 1 equal to 9 minus 5 into n plus 1, which is 4 minus 5n. If I simplify, so an plus 1 minus an equal to 5. Okay, 5 is a constant. There is no variable term in this, which means this equation will definitely form an arithmetic progression. Okay, so the progression terms are 4, 9, 14, 19, dash dash dash, and Sn equal to I need to find the first 15 terms, right? So n equal to 15. If I substitute all the required values, I will get S15 equal to 585. Okay. Yeah. Similarly, an equal to 3 plus 4n. We'll prove exactly same way. Just follow the same steps. Okay. So the common difference is 4, which is a constant. So definitely it will form an AP. Now this is the AP and Sn equal to 525. Okay. Next. If the sum of first n terms of a AP is 4n minus n square, what is the first term? What is the sum of first two terms? What is the second term? Similarly, find the third and 10th and nth terms. All these terms we need to find out. Okay. Sn equal to 4n minus n square. A1 equal to S1. Okay, right? Why this is? Because there is only one term. Whether it is you call it a term or sum of one term, which is same, right? So A1 equal to S1, which is 3. If I substitute n equal to 1. A2 is equal to, okay, S2 is 4, okay, and A2 equal to S2 minus S1, right? Sum of first two terms minus sum of first term. Then I'll get second term, that is A2 equal to 1. A3 equal to similarly S3 minus S2, which is equal to minus 1. A10 equal to S10 minus S9, okay. Sum of first 10 terms minus sum of first 9 terms. Difference is A10, 10th term. So minus 15. Okay, and nth term is basically if I substitute all the values here, what I will get is, and simplify, I get 5 minus 2n. Nth term is 5 minus 2n. Okay, next. A sum of 700 rupees is to be used. A sum of 700 rupees is to be used to give 7 cash prizes to students of a class for the overall academic performance. If each prize is 20 rupees less than the preceding one, find the value of each prize. Okay. So we know S7 equal to 700, n equal to 7. Okay, 700 rupees is the total price. There are 7 prizes we should buy. Okay, D equal to minus 20. Okay, Sn is given here. So which means if I substitute all the values, what I will get is A1. So A1 is nothing but 160. So that is the first prize. First prize is 160, and then next prize will be 20 less, that is 140, then 120, 100, 80, 60, 40. Okay, these are the value of the 7 prizes. Next. Find the sum of first 40 positive integers divisible by 6. Okay, so this is very easy. A1 equal to 6, D equal to 6, N equal to 40. Now I just need to find Sn S40 basically, right? S40 equal to, if I substitute all the values, I get 4920. Next. Okay, read the question. Basically, in a school, each class is going to plant some trees. Okay, first class will plant one tree, second class will plant second tree, and so on up to 12th class. There are three sections for each class. Okay, so the question is how many total plants will be planted. Okay, so this is very simple. The series is 1 comma 2 comma 3 comma dash 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 up to 12. Correct. There are three such series. Okay, so let's find the first sum of first series, n by 2 into a1 plus an. Okay, that is 12 by 2 into 1 plus 12, which is 78. Okay, one single series is 78. So the total number of trees planted by the three sections is equal to 3 into 78, which is 234. Next. Okay, read the question. There is a spiral wire. Okay, wire is put in a spiral shape basically. For the first semicircle here, the center is here A and the radius is 0.5 meters. Second semicircle is here, okay, down, and the center is at B and this radius is 1 meter. Third semicircle again, center here and it is here. Okay, so like this, a total of 13 consecutive semicircles are drawn, 13, okay, with the given wire, and is asking what is the total length of the wire. Okay, we know that the length of semicircle is pi r. Okay, and r is from 0.5 comma 1 comma 1.5 and so on. Okay, which means the series is the semicircle length of semicircle series is pi by 2, pi, 3 pi by 2 dash 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 up to 13 times. Okay, now once I know that this is the series, a1 equal to pi by 2, n equal to 13, d equal to pi by 2, right? If I substitute the values in Sn equation, I get total length of the spiral is 143 centimeters. Okay, next. Yeah, read the question again. There are 200 logs. Okay, and the logs are placed in this way. Okay, the bottommost will have 20 logs. Okay, then above that 19 logs are placed, above that 18 logs are placed, and so on. Okay, the question is how many rows are there, okay, to put to have 200 logs in this pyramid shape, okay, triangular shape or pyramid, whatever you call. Okay, for placing 200 logs, how many rows will be there, and what is the how many logs are there in the top row? These are the two things which we should calculate now. So the series is something like this: 20 comma 19 comma 18 dash dash dash. Okay, and we know that S of Sn equal to 200, d is equal to -1. Correct, we are reducing one log each row, and a1, that is initial number of logs, are 20. Okay, so this is the information we have. We don't have information about n, we should find n. Okay, so if you substitute in the Sn equation all the known values, you get a quadratic equation. Okay, that is n square minus 41n plus 400 equal to 0. Okay, if you simplify it, factorize and simplify, you get n equal to 25 and 16. Both are positive numbers and integers. So let's take both cases. For n equal to 25, a25, that is topmost row, how many logs are there? If I calculate, it is -4. Okay, so the number of logs cannot be negative, right? So this is not possible. -4 is not possible. For n equal to 16, a16 equal to 5, so this is possible. So topmost row will have 5 logs. Okay, and there are 16 rows. N equal to 16 and topmost row a16 is 5, right? So topmost row will have 5 logs. Okay, yeah, read the question yourself. There is a bucket placed here. Okay, and after 5 meters, there is a ball placed, and after that every 3 meters distance there is a ball placed continuously. Okay. Now a runner at bucket, starting from bucket, he will run all the way, pick up the first ball, come back and put it in the bucket, go again, pick up the second ball, put it back, third ball, put it back. Okay. So the question is, what is the total distance the runner has to run to collect all the 10 balls? Okay, there are 10 balls like this. Okay, how much distance, total distance covered by the runner to pick up 10 balls basically. Okay, so if you see, first we need to check the general equation, right? So first of all, to pick up the first ball, the runner will run only 2 into 5 meters, correct? 5 meters up and 5 meters back, to and fro, right? For second ball onwards, you will add, along with this 10 meters, 3 meters up and 3 meters back, 3 meters to 3 meters back, to and fro, right? So you will add 6 more meters extra, correct? 2 into 3, that is. So the runner will, the general equation for runner to pick nth ball is 2 into 5 plus 2 into n minus 1 into 2. Okay, if I simplify, okay, this is the series basically. For n equal to 1, n equal to 2, n equal to 3, I'll get 10, 16, 22. Okay, so a1 equal to 10, d equal to 6, n equal to 10. If I substitute all these values in Sn, I'll get 370. So the runner runs 370 meters to pick up all 10 balls. Yeah, this is the exercise 6.3. This video I will end here, and in my next video I will cover geometric progression. Wait for my video, and meanwhile keep solving the arithmetic progression problems from wherever you get. Okay, keep doing maths. Thank you.